This is your Gayathri. So now in this session we learn how to find the particular integral. When q of x is given, we can find the particular integral. So here we have different methods. So first method is when q of x is exponential form, which is e power ax. If q of x equals to e power ax, yp is generally yp formula 1 by f of d into q of x. When q of x equals to e power ax, we have to just replace d by a. So 1 by f of a into e power ax. 1 by f of a into e power ax. So now if f of a is not equals to 0, this itself the final solution. If f of a equals to 0, then you have to write into this form, which is x power k by k factorial into 1 by pi of a into e power ax. This is the solution when f of a equals to 0. So what is the method when q of x equals to e power x? Just you have to replace d by a. After replacing d by a, f of a equals to 0 or not equals to 0, we have to verify. If f of a equals to 0, this is the solution. If f of a not equals to 0, this is the solution. If f of a equals to 0, this is the solution. F of a not equals to 0, then this is the solution. F of a equals to 0, this is the solution. Now let us see one problem. Solve d square minus 4d plus 6 into y equals to e power 4x. So here we have to find the general solution. The general solution of the given higher order differential equation is y equals to yc plus yp, where yc is the complementary function and yp is the particular integral. Now how to find the complementary function? By considering the left hand side part. So now consider f of d into y equals to 0. Here f of d is d square minus 5d plus 6 into y equals to 0. So here f of d equals to d square minus 5d plus 6. To find the auxiliary equation, take f of m equals to 0. The auxiliary equation is f of m equals to 0. So to find the roots, we have to take the auxiliary equation, that is f of m equals to 0. M square minus 5m plus 6 equals to 0. After finding solve this, we get the roots are m equals to 2 comma 3. So 2 comma 3 are real and different roots. So how to write the complementary function? From previous class also we have practiced. So yc equals to c1 into e power 2x plus c2 into e power 3x. Now, so to find the particular, now we come to the particular integral. To find the particular integral, yp is 1 by f of d into q of x. Here what is the q of x in the problem? E power 4x. So 1 by f of d into e power 4x. So as I told it, just when q of x equals to e power ax, we have to just replace d by a. So here 1 by d square minus f of d means d square minus 5d plus 6 into e power 4x. So here a value is, what is the a value here? 4. Here a value is 4. So replace d by 4. So 1 by 4 square minus 5 into 4 plus 6 into e power 4x. So we eliminated d in the denominator. So we get e power 4x by 2. This is particular integral. So therefore the general solution is y equals to yc plus yp. So y equals to c1 e power 2x plus c2 e power 3x plus e power 4x by 2, where c1 comma c2 are arbitrary constants. This is the general solution of the given differential equation. I hope everyone understood. Let's see the next problem. Let's see the next problem. Solve. Everyone write. Solve. I hope everyone following my notes. So everyone should write the notes. So second problem, solve d square plus 5d plus 6 into y equals to e power minus 2x. d square plus 5d plus 6 into y equals to e power minus 4x. So solve means we have to find the general solution. So the general solution of the given differential equation is y equals to yc plus yp. So now first we have to find the complete YCF complementary function we have to find. So consider d square plus 5d plus 6 into y equals to 0. Here f of d equals to, what is f of d? D square plus 5d plus 6. So take the auxiliary equation. F of m equals to 0. That is m square plus 5m plus 6 equals to 0. So m square plus 2m plus 3m, 2 plus 3 5 and 2 3s are 6. So m equals to m plus 2 and plus m 3m plus 2 equals to 0. So m plus 2 into m plus 3 equals to 0. So m plus 2 m equals to minus 2 comma minus 3 are real and different only, right? Are real and different. So how to write the complementary function yc equals to c1 e power minus 2x plus c2 e power minus 3x. Now we have to find the, what we have to calculate to find the particular integral. So here itself I am writing to find the particular integral 1 by d square. So for particular integral yp equals to 1 by f of d into q of x. What is f of d? D square plus 5d plus 6 into e power minus 2x. Replace d by a, that equals to minus 2. A value is minus 2. So replace d by minus 2. Minus 2 whole square plus 5 into minus 2 minus 10 plus 6 into e power minus 2x, as usual you have to write. So 1 by 4. 4 minus 10 plus 6 into e power 2x. So here 1 by 10 minus 10, 0 you are getting. E power 2x we are getting. So here we can write two ways. So I'll tell you. See what you are getting. So this equals to 1 by 0 into e power minus 2x. So here f of a gets 0. So you have to write into the form x power k by k factorial into pi of a, 1 by pi of a into e power ax. Okay, this one you have to write. So 1 by, what are the values where, what is f of d? D square plus 5d plus 6 into e power minus 2x, right? Again we have to go back. 1 by d square plus 5d plus 6 into e power minus 2x. See, d square plus 5d plus 6 you write into terms of factors. So d plus 2 into d plus 3 into e power minus 2x. From this only we got the roots m plus 2 into m minus 3. So here same way we have written d plus 2 into d plus 3. See here which term gets 0. Here a value is minus 2 na. If you substitute minus 2 in this term get 0 or in this term get 0. In this term. If you replace d by minus 2 here, minus 2 plus 2, it is getting 0. So what is the power of this term? 1. That is k value. Okay. So x power 1 by 1 factorial. So x power k by k factorial. So k value how to find? I repeat once again how to find the k value. So first f of d you have to write into the factors form. So d square plus 5d plus 6 can be written into d plus 2 into d plus 3. So now a value is minus 2. In which term gets 0 after you replace d by minus 2, you have to observe. So this term here in this problem d plus 2. If you replace d by minus 2, this term is getting 0. So The power of this term is 1. So that is k value. So x power 1 by 1 factorial. And now remaining 1 by d plus 3. That is pi of x. Remaining this is pi of d, sorry. Remaining this is pi of d. So that is 1 by d plus 3 into e power minus 2x. This is pi of d. Now replace d by a here. So x by 1 factorial into 1 by minus 2 plus 3 into e power 2x. So x into e power minus 2x. Right. So now this is one way to find the solution, and another way, whenever you get replace d by f of a is getting 0, just you have to derivative and the derivative f of d. See, whenever you are taking the derivative, you finding the derivative of f of d. So you put x in the numerator. How many times you are differentiating? That number of times you put x into e power minus 2x. X by f of d is d square plus 5d plus 6. F dash of d is 2d plus 5 into e power minus 2x. Again replace d by minus 2 here. So x by 2 into minus 2 minus 4. Minus 4 plus 5 1 into e power minus 2x. So x into e power minus 2x. Actually this is the very easiest method to solve when f of a equals to 0. This is whenever it is asking, let's see, it compulsory we have to use some problems, we have to compulsory use this formula. Let's see, I will explain one problem to use this formula. So basically we use this formula which is taking the derivation. Whenever f of a is getting 0, you have to find immediately f dash of d. If f of a equals to 0, immediately you find f dash of d. So when you are taking the differentiate of f of d, you put x in the numerator. If you want to take second time derivative, again you have to put x1 once again in the numerator. So here I am going to find f dash of d. So I am putting x in the numerator here. Okay, f dash of d into e power minus 2x. So f dash of d is 2d plus 5. So e power minus 2x. Replace d by a. So 1 we are getting. Even though if you are replacing d by a here, again if you are getting 0, then you should take once again derivative. That time you have to find f double dash of d. When you are taking the derivative, again one more time you have to put x in the numerator. So here itself no need to find the second derivative, because first derivative itself we are getting the solution. So x by 2d plus 5 into e power minus 2x. So replace d by minus 2. So after replace d by minus 2, here f of this term is denominator is not getting 0. So now here itself we can complete the solution. X into e power minus 2x. So yp equals to x into e power minus 2x. Therefore the general solution is what? Yc equals to yp. Therefore the general solution is y equals to yc plus yp. So y equals to c1 e power minus 2x plus c2 into e power minus 3x plus yp is x into e power minus 2x. So where c1 comma c2 are is the general solution, where c1 comma c2 are arbitrary constants. Okay, let's see the next one more problem. Third problem. So solve d square plus 4d plus 13 into y equals to 2 into e power minus x. So everyone find the complementary function first. To find the complementary function, okay, consider left hand side part, that is d square plus 4d plus 3 into y equals to 0. So actually no need to write this one, directly you can take f of d equals to d square minus 4d plus 3. Okay, take the auxiliary equation f of m equals to 0, that implies m square minus 4m plus 3 equals to 0. Sorry, 13 equals to 0. 13. So 13, there is no numbers to multiply to get the multiples of 13, and if we add those numbers we will not get to 4. So now we have to apply, we have to find m equals to, by using this formula, minus b plus r minus root of b square minus 4ac by 2a. So m equals to minus b, what is b value? Here this is in the form of ax square plus bx plus c equals to 0, quadratic equation. Now b value is minus 4, so minus of minus plus 4 minus b plus r minus root of b square minus 4 into a into c, 13 by 2 into 1. So plus the m square plus 4, sorry, plus 4m plus 13. So here minus 4 we get. So minus 4 plus r minus 36 minus 36 by 2. So minus 2 plus r minus minus 4 plus r minus root of minus 36 means 6i by 2. So minus 2 plus r minus 3i. So m equals to minus 2 plus r minus 3i are complex roots. Complex roots. Now how to write yc? Yc equals to e power ax into c1 cos bx plus c2 sin bx. I told you, if m equals to a plus r minus ib form, then yc equals to e power ax into c1 cos bx plus c2 sin bx. Okay, so here a value is minus 2, so e power minus 2x into c1 cos 3x plus c2 sin 3x. So now find the particular integral. So the particular integral yp equals to 1 by f of d into q of x. 1 by f of d is d square plus 4d plus 13 into 2 into e power minus x. So now here a value equals to minus 1. Replace d by a, that equals to minus 1. 1 by minus 1 whole square minus 4 plus 13 into 2 into e power minus x. So 2 into e power minus x by 14 minus 10. So e power minus, already we have written e power minus x. So 1 by 5 into e power minus x. So that is yp. See, the these derivatives we are eliminating so that we get this answer. So y equals to yc plus yp, the general solution. Y equals to e power minus 2x into c1 cos 3x plus c2 sin 3x, plus yp is 1 by 5 into e power minus x. I hope everyone understood these problems. If you like, please subscribe my channel and follow my classes. Thank you.